Las Vegas! Happy New Year! Welcome to CES. Well, we have about 15 keynotes worth of material to pack in here. I'm so happy to see all of you. You got 3,000 people in this auditorium. There's 2,000 people in the courtyard watching us. There's another 1,000 people apparently in the 4th floor where there are supposed to be NVIDIA show floors, all watching this keynote. And of course, millions around the world are going to be watching this to kick off this new year. Well, every 10 to 15 years, the computer industry resets. A new platform shift happens. From mainframe to PC, PC to internet, internet to cloud, cloud to mobile. Each time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for a new computer. Except this time, there are 2 simultaneous platform shifts, in fact, happening at the same time. While we now move to AI, applications are now going to be built on top of AI. At first, people thought AIs are applications, and in fact, AIs are applications, but you're going to build applications on top of AIs. But in addition to that, how you run the software, how you develop the software fundamentally changed. The entire longer program the software, you train the software. You don't run it on CPUs, you run it on GPUs. And whereas applications were pre-recorded, pre-compiled, and run on your device, now applications understand the context and generate every single pixel, every single token, completely from scratch every single time. Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that 5-layer cake is now being reinvented. Well, what that means is some $10 trillion or so of the last decade of computing is now being modernized to this new way of doing computing. What that means is hundreds of billions of dollars, a couple of $100 billion in VC funding each year is going into modernize and inventing this new world. And what it means is $100 trillion of industry, several percent of which is R&D budget, is shifting over to artificial intelligence. People ask, where is the money coming from? That's where the money is coming from. The modernization of AI to AI, the shifting of R&D budgets from classical methods to now artificial intelligence methods. Enormous amounts of investments coming into this industry, which explains why we're so busy. And this last year was no difference. This last year was incredible. This last year, there's a slide coming. This is what happens when you don't practice. It's the first keynote of the year. I hope it's your first keynote of the year. Otherwise, you have been pretty busy. This is our first keynote of the year. We're going to get the spider webs out. And so 2025 was an incredible year. It seemed like everything was happening all at the same time, and in fact, it probably was. The first thing, of course, is scaling laws. In 2015, the first language model that I thought was really going to make a difference made a huge difference. It was called BERT. 2017, Transformers came. It wasn't until 5 years later, 2022, that ChatGPT moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important happened a year after that. The first O1 model from ChatGPT, the first reasoning model, completely revolutionary, invented this idea called test time scaling, which is a very commonsensical thing. Not only do we pre-train a model to learn, we post-train it with our reinforcement learning so that it could learn skills. And now we also have test time scaling, which is another way of saying thinking. You think in real time. Each one of these phases of artificial intelligence requires an enormous amount of compute. And the computing law continued to scale. Large language models continue to get better. Meanwhile, another breakthrough happened. And this breakthrough happened in 2024. Agentic systems started to emerge. In 2025, it started to proliferate just about everywhere. Agentic models that have the ability to reason look up information, do research, use tools, plan futures, simulate outcomes. All of a sudden, started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming at NVIDIA. Agentic systems are going to really take off from here. Of course, there were other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure, we could teach a large language model, a form of language model, to go understand that information, to understand its representation, and to turn that into an AI. One of the biggest, most important one is physical AI. AIs that understand the laws of nature. And then, of course, physical AI is about AIs interacting with the world, but the world itself has information, encoded information, and that's called AI physics. AI that, in the case of physical AI, you have AI that interacts with the physical world, and you have AI physics, AI that understands the laws of physics. And then lastly, one of the most important things that happened last year, the advancement of open models. We can now know that AI is going to proliferate everywhere when open source, when open innovation, when innovation across every single company and every industry around the world is activated at the same time. Open models really took off last year. In fact, last year, we saw the advance of DeepSeek R1, the first open model that's a reasoning system. It caught the world by surprise, and it activated, literally, this entire movement. It's really, really exciting work. We're so happy with it. Now, we have open model systems all over the world of all different kinds, and we now know that open models have also reached the frontier. Still solidly is 6 months behind the frontier models, but every single 6 months, a new model is emerging, and these models are getting smarter and smarter. Because of that, you could see the number of downloads has exploded. The number of downloads is growing so fast because startups want to participate in the AI revolution. Large companies want to, researchers want to, students want to, just about every single country wants to. How is it possible that intelligence, the digital form of intelligence, will leave anyone behind? And so open models has really revolutionized artificial intelligence last year. This entire industry is going to be reshaped as a result of that. Now, we had this inkling some time ago. You might have heard that several years ago, we just started to build and operate our own AI supercomputers. We call them DGX clouds. A lot of people asked, are you going into the cloud business? The answer is no. We're building these DGX supercomputers for our own use. Well, it turns out we have billions of dollars of supercomputers in operation so that we could develop our open models. I am so pleased with the work that we're doing. It is starting to attract attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains. The work that we did in proteins, in digital biology, La Proteina to be able to synthesize and generate proteins, OpenFold 3 to understand the structure of proteins, Evo 2, how to understand and generate multiple proteins, otherwise the beginnings of cellular representation. Earth 2, AI that understands the laws of physics. The work that we did with ForecastNet, the work that we did with CorrDiff, really revolutionized the way that people are doing weather prediction. Nemotron, we're now doing groundbreaking work there. The first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time or can think very quickly for not a very long time and produce very, very smart, intelligent answers. Nemotron 3 is groundbreaking work, and you can expect us to deliver other versions of Nemotron 3 in the near future. Cosmos, a frontier, open, world foundation model, one that understands how the world works. Groot, a humanoid robotic system, articulation, mobility, locomotion. These models, these technologies are now being integrated, and in each one of these cases, open to the world. Frontier humanoid robotics models open to the world. And then today, we're going to talk a little bit about Alpamayo, the work that we've been doing in self-driving cars. Not only do we open source the models, we also open source the data that we use to train those models. Because in that way, only in that way, can you truly trust how the models came to be. We open source all the models. We help you make derivatives from them. We have a whole suite of libraries. We call the NEMO libraries, physics NEMO libraries, and the Clara NEMO libraries, each bio NEMO libraries. Each one of these libraries are life cycle management systems of AIs, so that you could process the data, you could generate data, you could train the model, you could create the model, evaluate the model, guardrail the model, all the way to deploying the model. Each one of these libraries are incredibly complex, and all of it is open sourced. And so now, on top of this platform, NVIDIA is a frontier AI model builder, and we build it in a very special way. We build it completely in the open so that we can enable every company, every industry, every country to be part of this AI revolution. I'm incredibly proud of the work that we're doing there. In fact, if you notice the charts, the chart shows that our contribution to this industry is bar none. And you're going to see us, in fact, continue to do that, if not accelerate. These models are also world-class. All systems are down. This never happens in Santa Clara. Is it because of Las Vegas? Somebody must have won a jackpot outside. All systems are down. Okay, I think my system's still down, but that's okay. I'll make it up as I go. And so not only are these models frontier capable, not only are they open, they're also top the leaderboards. This is an area where we're very proud. They top leaderboards in intelligence. We have important models that understand multimodality documents, otherwise known as PDFs. The most valuable content in the world are captured in PDFs. But it takes artificial intelligence to find out what's inside, interpret what's inside, and help you read it. And so our PDF retrievers, our PDF parsers are world-class. Our speech recognition models, absolutely world-class. Our retrieval models, basically search, semantic search, AI search, the database engine of the modern AI era, world-class. So we're on top of leaderboards constantly. This is an area we're very proud of. And all of that is in service of your ability to build AI agents. This is really a groundbreaking area of development. You know, at first when ChatGPT came out, people said, you know, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it could memorize everything in the past, but it can't memorize everything in the future, in the current. And so it needs to be grounded in research. It has to do fundamental research before it answers a question. The ability to reason about, do I have to do research? Do I have to use tools? How do I break up a problem into steps? Each one of these steps, something that the AI model knows how to do, and together it is able to compose it into a sequence of steps to perform something it's never done before, never been trained to do. This is the wonderful capability of reasoning. We can encounter a circumstance we've never seen before and break it down into circumstances and knowledge or rules that we know how to do because we've experienced it in the past. And so the ability for AI models now to be able to reason, incredibly powerful. The reasoning capability of agents opened the doors to all of these different applications. We no longer have to train an AI model to know everything on day one, just as we don't have to know everything on day one, that we should be able to, in every circumstance, reason about how to solve that problem. Large language models has now made this fundamental leap, the ability to use reinforcement learning and chain of thought and search and planning and all these different techniques in reinforcement learning has made it possible for us to have this basic capability, and is also now completely open sourced. But the thing that's really terrific is another breakthrough that happened. And the first time I saw it was with Ervin's Perplexity, the search company, the AI search company, really innovative company. And the first time realized they were using multiple models at the same time, I thought it was completely genius. Of course we would do that. Of course an AI would also call upon all of the world's great AIs to solve the problem it wants to solve at any part of the reasoning chain. And this is the reason why AIs are really multimodal, meaning they understand speech and images and text and videos and 3D graphics and proteins. It's multimodal. It's also multi-model, meaning that they should be able to use any model that best fits the task. It is multi-cloud by definition, therefore, because these AI models are sitting in all these different places, and it also is hybrid cloud. Because if you're an enterprise company or you built a robot or whatever that device is, sometimes it's at the edge, sometimes a radio cell tower, maybe sometimes it's in an enterprise, or maybe it's a place where a hospital where you need to have the data in real time right next to you. Whatever those applications are, we know now this is what an AI application looks like in the future. Or another way to think about that, because future applications are built on AIs, this is the basic framework of future applications. This basic framework, this basic structure of agentic AIs that could do the things that I'm talking about, that is multi-model, has now turbocharged AI startups of all kinds. And now you can also, because of all of the open models and all the tools that we provided you, you could also customize your AIs to teach your AI skills that nobody else is teaching. Nobody else is causing their AI to become intelligent or smart in that way. You could do it for yourself. And that's the work that we do with Nemotron, Nemo, and all of the things that we do with open models is intended to do. You put a smart router in front of it, and that router is essentially a manager that decides which one of the tasks, based on the intention of the prompts that you give it, which one of the models is best fit for that application, for that solving that problem. Okay? So now, when you think about this architecture, what do you have? When you think about this architecture, all of a sudden you have an AI that's on the one hand, completely customizable by you. Something that you could teach to do your own very skills for your company. Something that's domain secret. Something where you have deep domain expertise. Maybe you've got all of the data that you need to train that AI model. On the other hand, your AI is always at the frontier, by definition. You're always at the frontier on the one hand, you're always customized on the other hand, and it should just run. And so we thought we would make the simplest of examples to make it available to you. This entire framework we call a blueprint. And we have blueprints that are integrated into enterprise SaaS platforms all over the world, and we're really pleased with the progress. But what we do is show you a short example of something that anybody can do.
Let's build a personal assistant. I want it to help me with my calendar, emails, to-do lists, and even keep an eye on my home. I use Brev to turn my DGX Spark into a personal cloud. So I can use the same interface whether I'm using a cloud GPU or a DGX Spark. I use a Frontier Model API to easily get started. I wanted to help me with my emails, so I create an email tool for my agent to call. I want my emails to stay private, so I'll add an open model that's running locally on the Spark. Now for any job, I want the agent to use the right model for the right task, so I'll use an intent-based model router. This way, prompts that need email will stay on my Spark, and everything else can call the Frontier model. I want my assistant to interact with my world, so I'll hook it up to Hugging Face's Reachy mini robot. My agent controls the head, ears, and camera of the Reachy with tool calls. I want to give Reachy a voice, and I really like 11 Labs, so I'll hook up their API.
Hi, I'm Reachy. Here you go.
That's great. With Brev, I can share access to my Spark and Reachy, so I'm going to share it with Anna.
Hey Reachy, what's Potato up to?
He's on the couch. I remember you don't like this. I'll tell him to get off. Potato, off the couch.
With all the progress in open source, it's incredible to see what you can build. I'd love to see what you create.
Isn't that incredible? Now, the amazing thing is, that is utterly trivial now. That is utterly trivial now. And yet, just a couple of years ago, all of that would have been impossible. Absolutely unimaginable. Well, this basic framework, this basic way of building applications, using language models, using language models that are pre-trained and they're proprietary, they're frontier, combine it with customized language models into a agentic framework, a reasoning framework that allows you to access tools and files and maybe even connect to other agents. This is basically the architecture of AI applications or applications in the modern age. And the ability for us to create these applications are incredibly fast. And notice, if you give it this application information that it's never seen before, or in a structure that is not represented exactly as you thought, it can still reason through it and make its best effort to reason through the data, the information, to try to understand how to solve the problem. Artificial intelligence. Okay, so this basic framework is now being integrated, and everything that I just described, we have the benefit of working with some of the world's leading enterprise platform companies. Palantir, for example, their entire AI and data processing platform is being integrated and accelerated by NVIDIA today. ServiceNow, the world's leading customer service and employee service platform. Snowflake, the world's top data platform in the cloud. Incredible work that is being done there. CodeRabbit, we're using CodeRabbit all over NVIDIA. CrowdStrike, creating AIs to detect, to find AI threats. NetApp, their data platform now has NVIDIA's semantic AI on top of it and agentic systems on top of it for them to do customer service. But the important thing is this. Not only is this the way that you develop applications now, this is going to be the user interface of your platform. So whether it's Palantir or ServiceNow or Snowflake and many other companies that we're working with, the agentic system is the interface. It's no longer Excel with a bunch of squares that you enter information into. Maybe it's no longer just command line. All of that multimodality information is now possible, and the way you interact with your platform is much more, well, if you will, simple, like you're interacting with people. And so that's enterprise AI being revolutionized by agentic systems. The next thing is physical AI. This is an area that you've seen me talk about for several years. In fact, we've been working on this for 8 years. The question is, how do you take something that is intelligent inside a computer and interacts with you with screens and speakers to something that can interact with the world, meaning it can understand the common sense of how the world works. Object permanence. If I look away and I look back, that object is still there. Causality. If I push it, it tips over. It understands friction and gravity. It understands inertia. That a heavy truck rolling down the road is going to need a little bit more time to stop. That a ball is going to keep on rolling. These ideas are common sense to even a little child, but for AI, it's completely unknown. And so we have to create a system that allows AIs to learn the common sense of the physical world, learn its laws, but also to be able to, of course, learn from data, and the data is quite scarce, and to be able to evaluate whether that AI is working, meaning it has to simulate in an environment. How does an AI know that the actions that it's performing is consistent with what it should do if it doesn't have the ability to simulate the response of the physical world back on its actions? The response of its actions is really important to simulate. Otherwise, there's no way to evaluate it. It's different every time. And so this basic system requires 3 computers. One computer, of course, the one that we know that NVIDIA builds for training the AI models. Another computer that we know is to inference the models. Inferencing the model is essentially a robotics computer that runs in a car or runs in a robot or runs in a factory, runs anywhere at the edge. But there has to be another computer that's designed for simulation. And simulation is at the heart of almost everything NVIDIA does. This is where we are most comfortable. And simulation was really the foundations of almost everything that we've done with physical AI. So we have 3 computers and multiple stacks that run on these computers, these libraries, to make them useful. Omniverse is our digital twin, physically based simulation world. Cosmos, as I mentioned earlier, is our foundation model, not a foundation model for language, but a foundation model of the world. And is also aligned with language. You could say something like, what's happening to the ball? And they'll tell you the ball's rolling down the street. And so a world foundation model, and then of course the robotics models. We have 2 of them. One of them is called Groot. The other one's called Alpamayo that I'm going to tell you about. Now, one of the most important things that we have to do with physical AI is to create the data to train the AI in the first place. Where does that data come from? Rather than, instead of having languages, because we created a bunch of text that are what we consider ground truth that the AI can learn from, how do we teach an AI the ground truth of physics? There are lots and lots of videos, but hardly enough to capture the diversity and the type of interactions that we need. And so this is where great minds came together and transformed what used to be compute into data. Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth, we can now selectively, cleverly generate data that we can then use to train the AI. So for example, what comes into this AI, this Cosmos AI world model on the left, over here, is the output of a traffic simulator. Now this traffic simulator is hardly enough for an AI to learn from. We can take this, put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from. And there are so many examples of this. Let me show you what Cosmos can do.
The ChatGPT moment for physical AI is nearly here. But the challenge is clear. The physical world is diverse and unpredictable. Collecting real-world training data is slow and costly, and it's never enough. The answer is synthetic data. It starts with NVIDIA Cosmos, an open, frontier world foundation model for physical AI. Pre-trained on internet-scale video, real driving and robotics data, and 3D simulation. Cosmos learned a unified representation of the world, able to align language, images, 3D, and action. It performs physical AI skills like generation, reasoning, and trajectory prediction. From a single image, Cosmos generates realistic video. From 3D scene descriptions, physically coherent motion. From driving telemetry and sensor logs, surround video. From planning simulators, multi-camera environments. Or from scenario prompts, it brings edge cases to life. Developers can run interactive closed-loop simulations in Cosmos. When actions are made, the world responds. Cosmos reasons. It analyzes edge scenarios, breaks them down into familiar physical interactions, and reasons about what could happen next. Cosmos turns compute into data, training AVs for the long tail, and robots how to adapt for every scenario.
I know, it's incredible. Cosmos is the world's leading foundation model, world foundation model. It's been downloaded millions of times, used all over the world, getting the world ready for this new era of physical AI. We use it ourselves as well. We use it ourselves to create our self-driving car, using it for scenario generation and using it for evaluation. We could have something that allows us to effectively travel billions, trillions of miles, but doing it inside a computer. And we've made enormous progress. Today, we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end to end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself, where we human drive it, using human demonstration. And we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human trained and as well as Cosmos generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all of population. However, it is very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And so let's take a look. Everything you're about to see is one shot. It's no hands.
Routing to your destination. Buckle up. You have arrived.